Hello dear students. So today's class we will see a few problems on eliminating the arbitrary function. So the first question is, so you need to eliminate arbitrary function from the equation z equal to xy plus f of x square plus y square. Okay. So നമ്മൾ last class കണ്ടത് your function is of the form f of uv equal to 0. Okay. For f of uv means you have f as capital F is an arbitrary function and the functions u and v, they are functions of x, y and z. So when you have an equation of the form f of uv equal to 0, ഒന്നെങ്കിൽ ആ equation that will be in the form f of uv equal to 0, or I can write it in the form u equal to phi of v or v equal to some phi of v, where phi is an arbitrary function. So here നമുക്ക് ആ representationലാണ് നമ്മുടെ ആദ്യത്തെ question കിടക്കുക. So it is of the form u equal to some f of v. ഇപ്പോൾ u എന്ന് പറയുന്ന function z minus xy ആയിരിക്കും, v എന്ന് പറയുന്ന function x square plus y square ആയിരിക്കും. So this can be done by directly differentiating. നമ്മൾ നേരിട്ട് differentiate ചെയ്യുമ്പോൾ നമുക്ക് f എന്ന് പറയുന്ന ഫംഗ്ഷനെ eliminate ചെയ്യാൻ പറ്റും. Okay. So since only one arbitrary function is involved, you are going to get a first order PDE. So on differentiating, now I will differentiate with respect to x and y. So on differentiating this with respect to x, so you will get p minus, we are differentiating with respect to x, so you will get y. Then here you have f dash of x square plus y square into 2x by chain rule. Now similarly differentiating with respect to y, so you will get q minus x varum, that is equal to f dash of x square plus y square into 2y. Now if you divide both the equations, you can see that f dash will go off and your equation will be free from the arbitrary function. So that will give the required partial differential equation. So the equation is py minus y square equal to qx minus x square, or that is py minus qx equal to y square minus x square. So similarly you have the second question. So you have z equal to x plus y plus f of xy. അപ്പോൾ ആദ്യം ചെയ്ത പോലെ തന്നെ differentiate with respect to x and y. അപ്പോൾ x വെച്ച് ചെയ്യുമ്പോൾ you get p equal to 1 plus derivative of y will be 0 with respect to x. So you get f dash of xy into y. അതുപോലെ when you differentiate with respect to y, so you will get q equal to 1 plus f dash of xy into x. So from here you can write p minus 1 equal to f dash of xy into y, and q minus 1 equal to f dash of xy into x. So on dividing, f dash of xy will go off, so you get p minus 1 by q minus 1 equal to y by x. So that gives px minus qy equal to x minus y. And the next question, we have z equal to f of xy by z. So differentiate with respect to x and y. And differentiating with respect to x, so you'll get p equal to f dash of xy by z. And now differentiate xy by z with respect to x. So by chain rule, you'll get z into 1 minus x into dou z by dou x will be p by z square into y. Y is constant. Okay. So this is the derivative with respect to x. Similarly on differentiating with respect to y, you will get q equal to f dash of xy by z. Then x is constant, so z into 1 minus y into dou z by dou y, which is represented by q by z square. So on dividing, f dash goes off, so p by q is y by x into, so z square and cancel out, divide above, z minus xp by z minus yq. So that implies px into z minus yq is equal to qy into z minus xp. So xy pq will cancel off, and here z is common in both terms. If z cancel am, that will give px equal to qy, which is the required first order PDE. And next one, if you have z equal to f of x minus y. So on differentiating with respect to x and y, so you'll get p equal to f dash of x minus y into 1, and q is f dash of x minus y. So on differentiating x minus y with respect to y, you'll get minus 1. So that gives p by q equal to minus 1, or p is equal to minus q. So this is the first type of function. So when you have in the form u equal to phi of v, where phi is an arbitrary function. So usually ചെയ്യുന്ന പോലെ differentiate ചെയ്യാം, നമുക്ക് easily f dash അതിനെ eliminate ചെയ്യാൻ പറ്റും. So that will give you a required PD. So next you will see the case where you have in the form f of uv equal to 0. Okay. So f of uv യുടെ case നമ്മൾ ഇന്നലെ കണ്ടു. So you are going to get a first order PD. So where these are the components of small p, small q, and the value on the right hand side. Okay. ഇന്നലത്തെ notes കണ്ടാൽ മതി. There we have seen this equation. So here u is x square plus y square plus z square, and v is z square minus 2xy. So dou of uv by dou of yz is, so that is uy uz, then vy vz. So you get 4 times yz plus xz. Dou of uv by dou of zx is minus 4 zy plus xz, and dou of uv by dou of xy is minus 4x square plus 4y square. So these are the components of coefficients of p, q, and this is the right hand side function respectively. So on substituting, you will get 4 yz plus xz p minus 4 zy plus xz q equal to minus 4 x square minus y square. So this is the required equation. And another question. So if you have f of xy plus z square, then x plus y plus z equal to 0. So your u is xy plus z square, and v is x plus y plus z. So finding the corresponding determinant. So dou of uv by dou of yz is, so u by uz by v by vz. So uy is x and uz is 2z, and vy and vz both are 1. So you'll get x minus 2z, and dou of uv by dou of zx is uz ux, vz vx. So you'll get 2z y 1 1, so that is 2z minus 1. And dou of uv by dou of xy is y minus x. So on substituting, so you are going to get the PD as x minus 2z into p plus 2z minus y into q equal to y minus x. So those are the different techniques of finding the solution of the PD. So we have seen 3 techniques. So one is by eliminating arbitrary constant. If the number of arbitrary constants and independent variables are the same, you are going to get a first order PDE. And the second case is when you have a function of the form phi of u equal to phi of v, where phi is an arbitrary function. And the third case was when you have an arbitrary function of the form f of uv equal to 0. Okay. നമ്മൾ കണ്ടിരിക്കുന്ന കേസ് എന്ന് പറഞ്ഞാൽ പി ഡി ഫോം ചെയ്യുന്നതാണ്. നമ്മൾ ഇപ്പോൾ ഫസ്റ്റ് ഓർഡർ പി ഡിസ് ഫോം ചെയ്യുന്നത് മാത്രമേ നമ്മൾ ചെയ്യുന്നുള്ളൂ. ഫോർ ഹയർ ഓർഡർ പി ഡിസ് വിൽ സീ ദ ഫോർമേഷൻ ലേറ്റർ. Okay. When you are studying the solution for higher order PD. Now today we will define basically what is called a solution of PD. അപ്പോൾ നമ്മൾ കണ്ടു, നമ്മൾ ഈ 3 ടൈപ്പ് കർവ്സ് 3 ടൈപ്പ് ഫാമിലി ഓഫ് സർഫസസ് എടുക്കുമ്പോൾ നമുക്ക് അതിൽ നിന്ന് കറസ്പോണ്ടിങ് ഒരു ഫസ്റ്റ് ഓർഡർ പി ഡി ആയിരിക്കും കിട്ടുക. സോ ഫസ്റ്റ് വി ഹാവ് ടേക്കൺ എ ഫംഗ്ഷൻ ഇൻവോൾവിംഗ് ആർബിട്രറി കോൺസ്റ്റൻസ്. Secondly, you have taken a function where you have taken an arbitrary function. So they are going to generate your PD. So looking back on the reverse way, ഒരു PD satisfy ചെയ്യുന്നത് പോലെ നമുക്ക് you can find functions involving arbitrary constants, or you can find arbitrary functions. So they will be the form of solutions of your first order PD. And so we will now see what are basically the solutions. Now, if you have a relationship of the form f of x, y, z, a, b, where a and b are arbitrary constants, then this will form a PDE of first order. That's what we have seen now. Okay. Now, any such relation which contains two arbitrary constants and which is a solution of a PDE. So, you have a relation connecting x, y, z involving two arbitrary constants and അത് ഏതെങ്കിലും ഒരു PDE satisfy ചെയ്യുന്നുണ്ടെങ്കിൽ അങ്ങനെയുള്ള സൊല്യൂഷൻസിനെയാണ് we call them as the complete solution or the complete integral. So, by complete solution or complete integral of a PDE, it means that is a function that satisfies your PDE and that is involving arbitrary constants a and b. So it is called the complete solution or complete integral. And now your PDE can have, so PDE can satisfy a relation of the form f of ub equal to 0. So where f is an arbitrary function. And if your PDE has such a solution, so such a solution is called the general solution or general integral of the PDE. So any relation of the type f of u equal to 0, so it is involving an arbitrary function where u and b are functions of x, y, z, and if it satisfies a first order PDE, so such a solution is called the general solution or the general integral of the PDE. So those are the two types of solution of the PDE. അപ്പോൾ നമ്മൾ പ്രോബ്ലം ചെയ്യുമ്പോൾ നമുക്ക് ഈ ടൈപ്പ് സൊല്യൂഷൻ ആയിരിക്കും നമ്മൾ കണ്ടുപിടിക്കാൻ പോവുക. Okay. And in the next lecture, we will look at how to find the solution of a first order linear PDE. So PDE of the form P of x, y, z into small dou z by dou x plus Q of x, y, z into dou z by dou y equal to R of x, y, z. That is the form of first order PDE. So next class we will see how to find the solutions or integrals of first order PDE. Thank you.